In this video, we'll look at how do we do the bridging out or bridging in operations. Here we assume that we already know the linked list, the independent sets, which is which are the elements marked with blue. Notice that in the internal memory this is obvious, right? So in this case, if I know the red element, I just go to blue, and then from blue I go to the green, and then I just add the weights, and then I delete this blue element, and then I put an edge from red to green. Okay? But if I want to do the same thing in the IO model, then for every deletion I might spend one IO, which is already too much because I don't want to spend capital N IOs. I want to spend much fewer IOs. So we cannot do the obvious solution that we typically do in the internal memory. So I have to do something much more clever. The solution is basically something like this. First, we make a copy of the original list. So now we have two copies of the same list. I don't quite understand the animations here, but I know the algorithm, so I'll try to explain it the way I understand it. Okay, after we make the copy, we sort one of them, let's say this one, based on the ID of the successor. This picture might look a little bit misleading, but I will explain what it means. Imagine that you have in the original element, you have an element over here that is pointing to an element over there. Okay? And I know where this successor of this element is. So for example, the element I points to a successor at position J. So this position is J in the array, right? Because I know the address of the successor. Okay? Then when I do the sorting, I place element I at position J. Right, so when I do this sorted list at position J, I place this element I. Okay. This is equivalent to sorting these elements when you take this outgoing edge as the key. Since for every element of the linked list, I know this value J, I could simply sort them using, say, merge sort, and by taking this value as the key instead of, say, this value. Okay, so therefore I will have these elements sorted based on the outgoing edge. So let's look at example. So this is the original array. This element points to the successor, which is at position 2, right? Because this is the second element of the linked list. So therefore this green element is placed at position 2. Let's look at the red element. Red element is point to this element, point to 8 as a successor, and this is at position 5 of the array. So therefore this red element is placed at position 5. The fact that they have the same number as their position that they go to could be a little bit confusing, but yeah, that's how the example is made, I guess. And similarly, this 8 element points to position 8, so therefore you just sort it based on 8. Okay. And of course, the whole point here is that you take these where they point to as the key, and then I could easily sort based on these keys, so I get this input. Okay. What is the major property of this way of doing this? It's because you will see that when I put them side by side, 2 points to 4, right? 2 is pointing to 4, 3 is pointing to 5, right? 3 is pointing to 5, 4 is pointing to 9, and so on, right? So in other words, when I look at this original element, so this is the original array, right? 3 is pointing to 3 is pointing to 5, 4 is pointing to 9, 5 is pointing to 8, 8 is pointing to 2, and etc. When you put them side by side, you'll see that exactly they're on top of each other, right? 8 is pointing to 2, 9 is pointing to 6, where is it? 9 is pointing to 6, and etc. Basically like this. Okay. And because of this property, I could just read these two lists block by block at the same time, and I get this successor information. For example, assume that block size is 3. Okay, so do this color. I read one block. I read one block from this list and one block from this list. Then I'll know that since 2 is pointing to 4, and I have 4's information, and I know that 4 is pointing to 9. So therefore I will know that 2 steps ahead from 2 I will get to element number 9. Similarly, 2 steps away from 3 I will get to element 8, and once I read, for example, this block, I will know that 2 steps from 5 I will get to element 2, or to this green element. This is how we can do bridging out by sorting based on the IDs. And obviously after the sorting step, we were basically done with scan time. And so this takes n over b IOs, this takes sort n time, also sort n IO, and then the remaining steps of the algorithm takes again n over b IOs. And after these operations, I will have the bridging out operation done. Bridging in is basically the same thing, except more or less it's in reverse. So that concludes how bridging out and in is done.